Okay, so number one, page 143, it says the graph is given. Tell whether f appears to be periodic. What do you guys think periodic might mean?
It does the same thing.
It does same thing over and over. Now it doesn't. Yeah, it does the exact same thing over and over. If so, give its fundamental period. We did this back when we were doing like the function, the sine function and cosine function. You guys remember the period and its amplitude, and then find f of 1,000. Also find f of negative 1,000. That means what is the function value at 1,000 and what is the function's value at negative 1,000? Gosh, they really have to do heavy labor next door. Must be Matthew then. I gotta peek now and see if it's actually. Not Matthew. Let's see who it is.
He's a bad man.
I would have been shocked. Matt is probably. I mean, if Brady was here, I imagine Matthew would be making Brady do it. That's more his speed. All right, number one. Does number one appear to be periodic?
Yeah.
Yes, it does. So, but yes.
What does periodic mean?
Dude, we just explained.
It starts doing the same thing over and over. What is the period? That means how long before it starts repeating itself? 6 is correct. One. The smartboard is crazy today, so we'll see some fun writing. It's not all me this time.
Is this like the negative b over 2a?
That is for graphing a parabola.
Parabola?
Yeah, you're thinking of something else. But no, it's not that. That was for trig functions. We had to do that. Okay, what is the amplitude? Now remember, amplitude was like how tall it was, but it wasn't the actual height. It was like how far from the middle does it go. So it's like the height divided by 2, basically. So yeah, the function from top to bottom is 2 tall. So basically it's 2 divided by 1 is 1. So the amplitude is 1. That's how much it's going up and down from its center. Find f of 1,000. What's f of 0 for number 1? 1. Okay, and then once you get to 6, it's back at 1, right? So, anybody have an idea how we could do this? Okay, every 6, it's going to start repeating itself. So basically, the remainder tells us how far after 6 it is. Calculators don't do remainders well. They can do mixed numbers, which are kind of the same thing, but sometimes they reduce the mixed number, which would screw up our answer. So the remainder tells you, like we're taking out the 6s, we're cutting this into 6s, and the remainder tells you how far past 6 we're going. Does that make sense? Like, for example, if they asked us what is f of 13, well, it's 1 step past the period starting to repeat itself, so it'd be the same thing as f of 1. Okay? Okay, anyway, so if I divide 1,000 by 6, bring it down to 0. You guys remember how to do long division? It's probably been a step or two. 6 is 30.
Short division?
You could do short division. 6 into 40, so it's 6 repeating. So the remainder is 4, which means whatever's happening at f of 4 is what's happening at f of 1,000. So what's happening at 4? It's -1. So the answer is f of 1,000 equals negative 1. Ooh.
Ooh.
You see that trick? Let's see if it does that again. It worked. I don't know what the.
Wouldn't the negative be the same?
No.
Wow.
So, well,
Oh, wait,
it's
it stops.
similar.
It stops.
It's similar.
Yeah.
If I divided negative 1,000 by 6, I'd get the same thing, but the remainder is like, yeah, it's going backwards 4. So what's happening backwards 4? Well, if you
There's 0, right?
if you start at 6 and go backward left 4, what's happening? You guys know what I'm saying? F of 0 and f of 6 are the same thing, because that's how long the period is. It's 6 long. So if my remainder is 4, if I count backwards from 6, that's the same thing as counting backwards from 0. The remainder is negative 4. Okay. But the problem is that graph does not show f of negative 4. So instead of f of negative 4, I'm going to go backwards 4 from 6, which is the same thing as going backwards 4 from 0. A visual would help, but I can't really. It'd take me like 2 minutes just to draw it. So, anyways, if we back up 4 from 6, we're at f of 2. So what's the function's value at 2? 1. Okay. Oh, come on.
Poopy.
Watch your language, man. It's not your first language, is it? I know how you feel.
Okay. Number 3, does that appear to be periodic? Which of those 4 is not periodic?
Number 4.
Number 4, right? So you don't have to do any work on 4, basically.
Yeah. My hair is
Okay, on number 3, yes, it is periodic. What is the period? How long before, after 0, before it starts repeating itself? 3 is correct. What is the amplitude? So what's the height of the function from bottom to top?
3.
1. It goes from 2 to 3, so it's 1 tall. It's 1 tall, so what's the amplitude?
1.
No.
3.
You cut it.
Half.
A half, right? The amplitude is a half. It's always half of the.
Oh, half that.
Yeah, because the amplitude is like how far from the center is it? What is f of 1,000? Okay, the period was 3. If I did 1,000 divided by 3, does anybody know what the remainder is going to be?
3, 3, 3.
1.5.
We'll do it then. 9. Well, the remainder is 1, 1, 1. Remainder is 1. So whatever is happening in the function at 1 is what's happening at 1,000.
So 2.
So it's up at 2, yeah. And if I divided negative 1,000 by 3, basically my remainder is like a negative 1. So what's happening at negative 1? It's up at 3. You can kind of see it on this one. If you couldn't see it, you would go to f of 3 and then back up 1. It's like f of 2. Okay, number 5. That wasn't too bad, right? Easy peasy.
No, I wrote all that on
No.
freaking 4.
It's a tough life. It's like a Brady moment.
May I go pee?
I don't know. May you? Okay.
Guess that
You're confused.
possible.
Well, I was gonna say can I, but then he said can.
Said it anyway. Number 5. Use the graph, blah, 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 shown at the right to sketch the graph of each of the following. What is the 2 in front of the function going to do? Probably better go to my graph screen. You guys know this?
Yeah, it'll make it do something.
It'll do something.
Stretch it.
Okay, it'll make everything twice as tall. So 0 times 2 is still 0, right? So where it's hitting at 0 is still going to be hitting at 0. But where it was at 1, where's it going to be? 2. So it's going to be stretching it. It's going to be twice as tall as that.
So do we have to draw this every time? Like, make the
Yeah, it doesn't say a single set of axes, does it? Because that would be a
Yeah, we have to do that
mess.
6 times for every problem.
Yay!
That's why I only put 8 though.
Are we gonna have to make 6 graphs? for
Really
every
quick.
problem?
It's quick and easy.
So yes.
See, yeah.
So
So look, just go you know, like so. I don't know how far they go, but just make sure it goes up to 2. There, done. 8A, the end, or 5A. Yeah, we got a whole piece of paper. What would multiplying by a half do to the graph? Only make it go up, well, no, it only makes it go up a half as far as what does the negative in front do though?
It flips.
Flips it upside down. So it's upside down. I guess if you want to do 2 on one graph, that might be okay, but it would get too messy. So it's upside down and it's only going half as far. So it's like that. Yeah, it doesn't take too long to graph.
I literally drew the lines on not the lines of the graph. I'm so smart.
Okay, C and D are getting a little tricksy.
that's cool.
Okay.
Josh, if you're in math, bring it to us and code.
So when you, I don't know if you guys know. You guys know what's going to happen on C?
It's gonna do some cool stuff.
It's going to do some awesome stuff. When you put the negative directly on the x, let's start with that. You guys know what happens? The x
And
values go from positive to negative, and it does a horizontal flip.
yeah, but on this that doesn't do anything.
On this one, it doesn't do anything because, yeah, it's the same on both sides. What is the 2? Well, it kind of does something because it's longer on the right, but I don't know if they just cut it off because, yeah, they probably just cut it off. Okay, what do you guys think the 2 is going to do?
It might go to, instead of hitting it like, I don't, it like it would be wider, right?
No.
Oh.
It actually, everything's going to happen twice as fast, so it's a horizontal compression.
Oh, so instead of skipping the space, it'll just hit it.
So it's gonna, instead of going like from here to here, it's gonna happen right there.
So it's a half.
So yeah, like everything is happening twice as fast.
Do you have another separate graph we could use?
I said you could put a couple on one graph. You can't, don't put all 6 on one, then I'm not gonna be able to read that.
Yeah.
Spend an hour staring at one problem, trying to figure it out. Okay, so if the 2 on the x makes everything go twice as fast. What's the 1/2 on the x do?
Goes along.
Yeah, makes it go half as fast, so it's a horizontal expansion, stretch. Yeah, I think they just say stretch. It's going to be twice as long. So starting at 0, it's going to go all the way over there before it gets up.
Is that D or C?
That was D. C was this one. Quick hills.
Oh, is it like
3 is slow hills. That was C. A and B were first.
is
Okay.
Yeah. Just been connected.
What happens when you put a minus 1/2 directly on the x?
what happened?
Huh?
Oh wait.
Okay, it affects the x motion, but it always does the opposite of what you might guess. It actually moves right. The whole graph moves right 1/2.
So it hits like a halfway point instead of a
So
zero.
yeah, just start at like the halfway and go up to half and half and half, like that. I guess just do a few hills. They only drew 3 hills.
Why'd you do
3.5.
something very cheap?
So it starts at.
Starts at a half,
Oh,
moves the whole graph moves 1/2 to the right. And okay, are we done here?
No.
Okay.
You're bringing this whole class in.
What?
I said you're bringing this whole class in.
I go back to my thing.
Okay. On F, what does the negative on the x do again? We kind of mentioned this earlier.
It flips it. Flips.
Okay, horizontal flip on 5, that doesn't happen to matter. Oh shoot, I just saw 6. I forgot about that one.
So far, so you just move it up one
Yeah, so it just moves up
What
one.
are those hockey sticks on 6?
then. You just move one basically.
No, it rounds everything down to the next integer. Like, so if it,
So instead of this
if x is worth 5.5, then y is worth 5, or, you know.
why not C?
That's what these symbols mean, like round it down to the,
Is it always around that?
that symbol does, yeah. So it's 5.9. If x is 5.9, then the y value is 5. Until you get up to 6.
Six doesn't look very fun.
Yeah. Sorry. I just have to explain something again. Got some explaining to do. So this one was supposed to be 1 up. So it's, you know, that.
Now is this number 5?
Yeah.
How many of these are there?
Probably 10.
Actually, in the problem, they kind of explain it. Now that I look at it, it says the greatest integer function. I don't know how to read that. I don't think I've ever heard it said before. Y equals blah, blah fancy things x gives the greatest integer less than or equal to x. So in other words, I kind of said it earlier. If x is worth 5.7, then the y value is worth 5. That's what's going on. So on the graph, if you look over at like where's 1.9 at for the x and you go up, the y value is 1. The function value is 1.
Can you say that? What did you just say?
So
Sorry,
there's a point at 1 point. 1.91, that's a point on the graph, right? 1.81, 1.71, those are all points on the graph. But when you get to 2, it goes to 2, and then it flips. So they're basically, whatever the x value is, they round down to the next y value in integers. So 2.1, 2, and so on. So if it's 1.7, 1.8, 1.9, 1 point whatever, the function value is 1. If it's 2, 2.1, 2.3, whatever, the function value is 2. And it looks like, they drew it in the picture, it looks like a stair step.
Is 0 an integer?
0 is an integer. Yep, everything on the number line basically is an integer. The x-axis, like a number line. Okay, thus 2.1 equals 2 and negative, okay, that's an important point. Negative 3.1 equals negative 4, because you go down. Negative 4 is less than negative 3.1. Use the graphs of this function shown at the right to sketch the graph of each of the following. We'll just stop after 6. I know I always go too far and keep it opening. Okay, what do you think is going to happen for a? If you do 1/2 times the entire function. It's kind of like 5b, right? What happens when you multiply the function by 1/2?
It's upside down.
Okay, it gets half as tall, so it's a vertical compression. So where it is down at -1, it's going to come up to -1/2. So right here will be like that. And where it was up at 1, when you multiply 1 by 1/2, it drops down to 1/2, right? So that one will be a 1/2 step up. Right there. Whoops,
Yeah, I was about to say.
I skipped one.
Wait.
I skipped the 0 one. That's still, 1/2 of 0 is still 0. So it should look like, whoops. There we go. So where it was up at 1, now it's down at 1/2. And where it was at 2, what's 1/2 of 2? 1. So it's only up at 1. They only drew those 4. I kind of need to zoom in, don't I? I wonder if I could. Can you zoom in? Let's see. Well, I can expand it. Kind of.
Yeah.
Oh, really?
Wall clicking.
Yeah, that's better. Beautiful. Oh, what happened to the line?
I see.
Why are you not staying down? Don't like it. Okay. So, I'm settling. All right. B. What happens when we multiply the function by 2?
What happened?
You guys tell me.
It flips and it's stretched up and
Okay, it gets twice as tall. The whole function gets twice as tall. What's the negative in front of the 2 do? Flips it upside down. So where it was at -1, the function was at -1. What's -1 times -2? Positive 2, right?
Positive.
So where it was at -1 down here, it's going to flip up and be twice as tall, so it's at +2. So, good grief. it's just gonna look ugly now. And then, so at the one at 0, 0 times -2 or whatever is still gonna be at 0. So that's not gonna move. Okay, where it was at 1, what's 1 times -2? -2, so it's gonna be down here at -2. And where it was at -2, where is it gonna be, or was at +2, where is it gonna be now? -4. So it's twice as tall, twice as spread out vertically, and it's flipped upside down. Okay, C. What's the negative in front of the x do? This is the third time we've asked this one today. No, the negative.
Oh, flip.
Okay,
Horizontal.
horizontal flip, which that does actually make a difference on this one. What does the 1/2 in front of the x do? We had one of these last time. Makes everything happen slower, half as fast, so it's a stretch horizontally. So I'm gonna do this one backwards. Since we're flipping right to left, it'd probably be easier to go backwards on this one. So if I flip that bottom line from left to right, like this, and then I stretch it, it'll be like this. So it's going from there to there now. Whoa. And then the next one, same thing. It's not going up or down anymore, so that's good. But it's stretched out. I think you guys can do the other two from there. Just keep the stairs going.
Why do we have a knot?
Oh my gosh, I didn't even bring that up.
A nap time?
Yeah. I feel like we needed more than
Because you're a grown boy.
yeah.
You need your nap. Other cultures do have afternoon naps. They even have words for them.
Wait, really?
What's it in Spanish, Daniel?
I
I should know this. In Chinese, it's shoshi. Out of all the words. It's so Daniel, if you claim English as your second language, then you gotta speak Spanish.
He just says that as an excuse for things. That's not true.
I used to know the word. All right.
I don't know.
No, you don't.
I'm more American.
Where are we at? I forgot. D?
Runzy, yeah.
Okay. What happens if you do a 2?
It goes twice as fast.
Happens twice as fast, which means it's a horizontal shrink. So
Let me just go back.
at 0, it's always like the same. So it's still, oh yeah, circle looks weird, but like that. Shrinking, amazing shrinking. Okay.
Did we do it wrong?
The board won't, I can never tell what's gonna come out when I draw the board. You guys maybe know what comes next, just keep the stairs going. Should be a dot right there in the middle.
No, you son.
What?
Just kidding.
Is that on fire?
No, I said I don't know about you son.
Oh.
Okay,
I don't want another.
on E, what does the -1 directly on the X do to the graph?
It moves it to the left.
No, it
To
always,
the right, to the right.
yeah, it does the opposite, so it does right 1. So I'm just gonna let you guys do it. This isn't even anyway. Just move
Yeah.
move right 1.
I don't trust myself.
I trust you, Dave.
So just look at the picture that they drew and move them all over
To the right.
to the right.
One more.
Okay. What does F do? What is the 2?
It goes up.
Okay, the graph moves up 1, but what else? This is a tricky one. What else happens with it?
Oh, it's upside down.
Oops.
It grows
Taller.
Oh.
gets taller by times 2.
Not gonna let me do that.
It looks like a B except.
Whoa. There we go.
Isn't it just B except flip?
There's no flipping.
No,
Flip-
B
flip.
was already flipped, so it reflipped it.
What are you talking about?
Oh,
You get it?
No.
I get what you're saying.
It's-
Thank you, Susie.
it's twice as tall, but it's also 1 higher. So
Oh no, it's gonna intersect.
let's do it step by step here. So you guys see the first step where it's at -1, right?
Sure.
If you took that times 2 and then added 1, where would it be? What?
-1. Right?
-1. So it actually doesn't change on that step. That's the only one that'll be in the same spot. So yeah, the first step is normal. I always forget is the open circle on which side. Okay, where it is at 0, so basically you do 0 times 2 plus 1. Where's it gonna be? 1. So you see how it's twice as tall as it was, but everything's also shifted up 1. Okay. When the function was equal to 1 on the third step, what is 2 times 1 plus 1?
It is.
3. It's up here 3. So you kind of see the pattern, right? I probably didn't even need to ask that question. So just do your next step similar. And then do 1 through 6 for homework.